Imagine a drop of food coloring in a glass of water. How fast it mixes depends on two things: how much you stir, which we call convection, and how much the color spreads on its own, known as diffusion. The Peclet number helps us understand which process is more important. In simple terms, the Peclet number is like a scorecard for fluid flow. It tells us whether convection or diffusion is the dominant process in a particular situation. A high Peclet number means convection or bulk movement is the main driver. A low Peclet number means diffusion, or random movement of molecules, is more important. Understanding the Peclet number is crucial in many fields, from designing efficient mixing systems to predicting pollutant spread in rivers. Let's break down the two key players in fluid dynamics: convection and diffusion. Convection is like a flowing river carrying leaves downstream. It's the movement of a fluid, like water or air, that carries along anything suspended in it. Diffusion, on the other hand, is like the scent of freshly baked cookies spreading through a kitchen. It's the gradual movement of particles from an area of high concentration to low concentration. Both processes happen simultaneously, but their relative importance depends on the specific situation. That's where the Peclet number comes in handy. The Peclet number, often abbreviated as P, is calculated using a simple formula: P equals L times V divided by D. Don't let the letters scare you. Here's what they mean. L is the characteristic length scale. This is the size of the system we're interested in, like the diameter of a pipe or the width of a river. V is the velocity of the fluid. This tells us how fast the fluid is flowing. D is the diffusion coefficient. This represents how fast the substance we're interested in spreads out on its own. By plugging in these values, we get a number that tells us whether convection or diffusion is the dominant force in our system. Section 4. High Peclet, Low Peclet. What does it all mean? Now that we know how to calculate the Peclet number, let's see what the results tell us. A high Peclet number, much greater than 1, indicates that convection is the dominant transport mechanism. This means the fluid flow is strong, and things are moving quickly due to the bulk motion of the fluid. A low Peclet number, much less than 1, means diffusion is in charge. In this case, the fluid flow is slow or negligible, and particles mainly move due to their random motion. For example, a fast-flowing river with a high velocity and large width will have a high Peclet number. In contrast, a stagnant pond with little to no flow will have a low Peclet number. Section 5. Peclet numbers in action from rivers to rooms. Let's look at some real-world examples to see how Peclet numbers play out. In a rushing river, pollutants are quickly carried downstream by convection, indicating a high Peclet number. In a still pond, pollutants spread slowly through diffusion, showing a low Peclet number. Spray perfume in a room without a fan, and the scent spreads slowly by diffusion, which is a low Peclet number. Turn on a fan, and convection takes over, quickly distributing the scent, indicating a high Peclet number. Add food coloring to a glass of water without stirring, and it diffuses slowly, showing a low Peclet number. Stir the water, and convection quickly mixes the color, indicating a high Peclet number. Hot water flowing through a pipe loses heat to the surroundings. At high flow rates or a high Peclet number, convection dominates heat transfer. At low flow rates showing a low Peclet number, diffusion becomes more important. Understanding these everyday examples helps us grasp the significance of the Peclet number in various situations. Section 6. Tiny Tech, Big Impact. Peclet numbers in microfluidics. Microfluidics is the science of manipulating tiny amounts of fluids. Think lab-on-a-chip devices for medical diagnostics or inkjet printers. In these tiny systems, Peclet numbers are crucial for controlling fluid flow and mixing. Because the characteristic length scales are so small, even slow flows can result in high Peclet numbers. This means convection often dominates in microfluidic devices, allowing for precise control over fluid movement and rapid mixing. This is essential for applications like drug delivery, chemical reactions, and biological analysis. Section 7. The Power of Peclet. Why understanding matters. The Peclet number might sound like a complex concept, but it's a powerful tool for understanding fluid dynamics in many different contexts. By considering the interplay between convection and diffusion, we can predict how things will mix, spread, and interact in various environments. From designing efficient mixing systems to understanding pollutant transport in the environment, the Peclet number helps us make informed decisions and solve real-world problems.